Okay, so we're going to handle 1 and 2 here in this film. So for the following collision problems, solve, then identify the type of collision. So we have a 21,000 kilogram train car. So we'll call that mass A. And that mass A will be 21,000 kilogram, travels on a track at a speed of 20 meters per second. So V1A is 20 meters per second. It collides and couples. That immediately tells me what type of collision this is. So this is perfectly inelastic. Okay, if they collide and stick together. Collide and couples with a 27,000 kilogram mass B, 27,000 kilogram initially at rest. So V1B is going to be 0 and with brakes released. What is the speed? That's just there to tell you that it's not like locked into place, that it's free to move. What's the speed of the two cars after the collision? So what we want to know is V2. All right, so let's go ahead and take a look at the equation first and then solve for V2, and then we'll plug the numbers in at the end. All right, so our collision problem for perfectly inelastic is mass of A times V1A plus mass of B V1B is equal to mass of A plus mass of B times V2. All right, so we do know that initially this guy is at rest. So in order to solve this, what I'm going to do is divide both sides by mass of A plus mass of B. Mass of A plus mass of B. These are going to cancel out, and I'm left with V2. So I can rewrite this as V2 equals mass of A, V1A over mass of A plus mass of B. So now I've got it down to a really nice, concise problem. I would be careful about putting this particular equation in your book unless you're specific about this thing having a second object with the initial velocity of 0. So V2, we've got 21,000 kilograms times 20 meters per second over, let's see here, 21,000 kilograms plus 27,000 kilograms, okay? And then by the time I do the math on that, please make sure that you pay extra close attention to the parentheses when you do your math on your calculator. Otherwise, it will not divide by that whole quantity. So we got that, and then that becomes 8.75 meters per second as our answer. Okay. All right, so let's look at number 2. We have a bullet fired at a 4.5 kilogram block initially at rest. Okay, so we're in a similar type of situation. Mass of A is 0.03 kilograms. Mass of B is 4.5 kilograms. We don't know what V1A is, but we know that V1B is going to be 0. The bullet moving with an initial speed of 500 meters per second becomes stuck in the block. We know what kind of problem this is. Perfectly inelastic. Okay, it gets stuck in the block. What is the speed of the system after the collision? So we want to know V2. All right, so here is, I just told you to be careful about just copying down that same equation. But in this case, it's accurate, right? Because we have the same situation as we had up here where my second object is at rest. It's V2 that I'm finding, which is my final. So that's going to end up being MA V1A over MA plus mb. So I'm going to go ahead and copy that equation down here. So ma v1a over ma plus mb is equal to v2. Again, we're looking at the logic that went through this. So if you did not get the equation correct, please go back to the previous question here. All right, so that's my velocity. And so now it's just a matter of plugging in all my numbers. So 0.03 kilograms times 500 meters per second over 0.03 kilograms plus the block is 4.5 kilograms. So by the time I add that up together on the bottom and divide it into what's left, I have a final velocity of 1.32 meters per second. That seems kind of weird, but 4.5 kilograms of block is pretty big. And the bullet is so tiny. The transfer of momentum is not going to be that large. So that is what we've got. All right. That takes care of this one. We'll tackle number 3 and 4 in the next film.